Hello everyone, welcome to In 5 Minutes. In this video clip, we'll discuss one question on mesh analysis. The question is, find the current through 4 ohm resistance using mesh analysis. In mesh analysis based questions, we have to first identify the meshes available in the circuit, and in every mesh we have to define a current, a mesh current, and write down KVL equations in each and every mesh. If there is a current source being shared by the two meshes, then we apply the concept of super mesh. Now in this particular network, you can see there is no current source, so there is no question of having a super mesh that we have to apply. You can see there are three meshes given in this particular network, so let us quickly define the three currents. Let me take this current as I1, this as I2, and finally current in the third mesh as I3. When the directions are not given, we can choose our own directions, and you can see the current through 4 ohm is going to become nothing but I3. So let's start with the solution now. We will first consider mesh number 1. So KVL in mesh number 1 will be written with respect to I1. So let's start from this particular point. The first voltage is plus 12 because we are going from negative to positive terminal, so it's positive voltage. Next, voltage across 2 ohm resistance will be nothing but 2I1. Because we are traveling in the direction of current is going upward, we are also traveling in the clockwise direction, so the drop will be negative, minus 2I1. Next, the voltage across 10 ohm resistance will be current through 10 ohm resistance into 10. Now you can see that 10 ohm resistance is part of both the meshes, so I will define a downward current, and that will become I1 minus I2. That is because I1 is also flowing in downward direction through 10 ohm resistance, and because the current is downward and we are also traveling in the downward direction, the voltage drop will be negative. That will be I1 minus I2 multiplied by the resistance, which is of 10 ohm. The next drop is across 1 ohm resistance. We are now going towards left. We will also define current through 1 ohm resistance towards left, which is same as the direction of I1, and hence the current will be I1 minus I3 because 1 ohm is being shared by both the meshes. And you can see why are we taking difference, because not just because the resistance is being shared by the two meshes, we are taking difference because I1 and I2 flowing in the opposite direction, I1 I3 flowing in the opposite direction. That's the reason we are taking difference here, and this minus sign we are taking because the overall current I1 minus I2 and direction of travel both are same. Similarly here you can see I1 minus I3 will flow towards left, and we are also traveling towards left. So once again it's minus I1 minus I3, and the resistance value is 1, so we just multiply by 1 and equal to 0. Let's simplify the whole thing. You can see, so I'll just keep this 12 as it is. Combine all the I1 terms. So all the I1 terms is 2I1 here. This will be 10I1, and this will be I1 with minus sign. So that gives me 13I1. Minus minus I2 will become plus 10I2 because there is 10 multiplied with this entire bracket, and minus minus plus I3, this is into 1, so it remains plus I3 equal to 0. Now let's do one thing, let's send all these terms on the other side. So my equation will become 13I1, I'm making it plus, so this will be minus 10I2 minus I3. This is as good as sending all these terms on one side and this on the other side, so 12. I'm changing the signs of the I1, I2, I3 terms, so the sign of 12 does not change. This is my first equation, equation number 1.